Hello, lovely people. How are you doing? Welcome back to another video where we are looking at exam questions on differentiation. So, here we have this question. The curve C has equation y equals x over 9 plus x squared. Use calculus to find the coordinates of the turning points of C. So, clues here. Calculus implies either differentiation or integration. Working out the turning points implies differentiation, i.e. the stationary points. So to do part one, we see that it's a quotient because you've got x divided by 9 plus x squared, so it's the quotient rule. So let u equal the top function, which is x, and v equals 9 plus x squared. That means du dx is equal to 1, dv dx is equal to, 9 differentiates to 0, and the x squared becomes 2x. And our dy dx, or the quotient rule, is dy dx equals v du dx, take away u dv dx, all divided by v squared. Okay, and that is going to be, so v is equal to 9 plus x squared. Du dx is 1 minus u, which is x, times dv dx, which is 2x, and that's all divided by v squared, which is 9 plus x squared, all squared like that. Okay, now that is our our dy dx even. We could write this in other ways, but the main goal is to work out the turning points. So we need to make this equal to 0. So now if we make this equal to 0, multiplying both sides by 9 plus x squared squared gives us 9 plus x squared times 1 minus x lots of 2x is equal to 0. And if we just tidy up the left-hand side, so expanding this bracket, we just get 9 plus x squared. And then it's take away 2x squared, which equals 0. This simplifies to 9 minus x squared, which equals 0. Factorizing by the difference of two squares, we get 3 minus x, 3 plus x, which equals 0, which tells us that x is equal to 3 or x is equal to minus 3. And then the question says coordinates. So we need to also work out the y coordinates. And we know that y is equal to x over 9 plus x squared. So let me just write that here. Y equals x over 9 plus x squared. So that means that y would equal, well, 3 over 9 plus 3 squared. So 3 squared is 9, 9 plus 9 is 18, 3 over 18, or 1 over 6. And then here we have minus 3 over 9 plus, well, minus 3 squared is again 9, so it's minus 3 over 18, which is minus a sixth. So our coordinates are indeed 3 a sixth, and we've got minus 3 minus a sixth. Okay, now let's go on to the second part of the question. And it says, given that y is equal to 1 plus e to the power of 2x to the power, all to the power of 3 over 2, find the value of dy dx at x equals ln of 3. Okay, so let's just put part 2. Let's go on a new page, I think. I think that's a good way to do it. So we've got y equals e to the power of 2x to the power of 3 over 2. So y equals e to the power of It was 1 plus e to the power of 2x. 1 plus e to the power of 2x to the power of 3 over 2. Was that it? It was, yes. It's this bit here. I'm going to find dy dx at x equals a half ln 3. So dy dx at x equals a half ln 3. So here we can use a chain rule. So let u equal 1 plus e to the 2x. So we end up with y equals u to the power of 3 over 2. And we have du dx, which is equal to e to the power of 2x is going to be differentiated using an inner chain rule as well. So the 1 goes to 0, and then we have e to the power of 2x because e to the power of something differentiates to e to the power of that something multiplied by the derivative of 2x, which is 2. So that simplifies to 2e to the 2x. And then here we have dy by du, which is equal to 3 over 2u, bringing the power down. Take 1 away from the power to the power of a half. So we have dy dx, which is equal to, just writing out the chain rule, equals dy du multiplied by du over dx. And dy du is going to be 3 over 2u to the power of a half. Du dx is going to be 2e to the 2x. Okay, and then simplifying, that gives us, well, 3 over 2 times 2 is 3. U was equal to 1 plus e to the 2x. So instead of writing u to the half, I'm going to write 1 plus e to the power of 2x to the power of a half. And then I've also got the e to the power of 2x. So that's dy dx for us. And it says at x equals half ln 3. So we need to find exact values. So we need to substitute x equals a half ln 3. So at x equals a half ln 3, comma, dy dx is equal to, so we've got 3 times 1 plus e to the power of 2 times, and then I'm going to replace x with a half ln 3. A half ln 3, that, to the power of a half, and then e to the power of 2 lots of, again, a half ln 3. Okay, so then that equals, so we've got 3 times 1 plus e to the power of ln 3, because the 2 times a half gives you just, well, 1. So we just have 1 lots of ln 3. And then that's to the power of a half. And then times e to the power of, again, 2 times a half is 1, so it's just e to the power of ln 3. Okay. And then, now that we've got that bit simplified, we've got 3 lots of 1 plus e and ln, because they're right next to each other like this, we can cancel. So that just leaves us with 3, because e and ln have cancelled, so we're just left with 3, like that, to the power of a half. And also the same is true here. E and ln cancel, so we end up with just times 3 again. And then 3 times 3 is 9. And then 1 plus 3 is 4, so it's 4 to the power of a half. That's equal to 9 times 2, because 4 to the power of a half is the square root of 4, which is 2. And that is equal to 18. And that is our value. That's the value of dy dx at x equals a half ln 3. So that's that question there done. Moving on to this question now. It says find dy dx using the product rule for differentiation. So that's good. They've told us what they want us to do. So it's pretty good. So we let u equal x squared, v equal e to the power x. We have du by dx is equal to 2x, dv by dx equals e to the power of x. Okay, then the product rule for differentiation, just going to write it here. Dy dx is equal to u times dv dx plus v times du dx. So that is going to be u, which is x squared, dv dx, which is going to be e to the power of x, plus v, which is e to the x, and then times du dx, which is 2x. So that's 2x e to the x, those two things multiplied. And, well, there we have it. Okay, part B, hence find the coordinates of the turning points of C. So we need our dy dx to equal to 0. So taking this expression, but what I am going to do now is factorize this. So I can see that I can factorize an x and I can factorize e to the x. So x e to the x, open bracket, x, because x times x gives you the x squared, plus 2, and then that equals 0. So either this part of the product, x times e to the x equals 0, or x plus 2 equals 0. We've got the product of two things that give you 0. So that means that x is going to be equal to 0. Well, we know e to the x is never 0, but this x over here can be 0, which makes this 0. Or x is equal to minus 2. Okay, then the next part of the question is to work out what d2y by dx squared is. Okay, this is fun. So what we need to do is take this function and we need to differentiate what we've just gotten. So we are finding d dx with a derivative of x squared e to the x plus 2x e to the power of x. So here it would be tempting to just go product rule, but if we look very carefully, in the first part they asked us to differentiate x squared e to the x. So we've actually already got the answer for that. This part, so this part we already know is equal to x squared e to the x plus 2x e to the x. And then it's just this part that we have to differentiate via a product. So changing colors, let's go pink. So let u equal 2x. And then we've got du dx, which equals 2. V equals e to the x. Dv dx is equal to e to the x. And then again, the rule is u dv dx plus v du dx. So that becomes u times dv dx, which is 2x e to the x, plus v du dx, that's e to the x times 2, or 2 e to the x. So putting everything together now, we've got this first part, plus this second part, and using, oh, no, that's not a good color, this dark blue, our final answer, d2y by dx squared is equal to x squared e to the x plus 2x e to the x plus this part, now the pink part, 2x e to the x plus 2 e to the x. Okay, and now we can simplify this to x squared e to the x plus, we've got 2x e to the x plus another 2x e to the x, so that's 4x e to the x plus 2 e to the x. And it says in part D, differentiate, determine the nature of each turning point of the curve C. So we need to substitute our turning points or our values into this. And actually, I just realized, really, really bad. In part B, I didn't actually finish the question. So let me just really quickly do that. We've got here, we actually need to work out the y coordinates. If we know x equals 0, and we know y equals x squared e to the x, that means the y, so x equals 0, y equals 0 as well, substituting it back in here. And then if x equals minus 2, y equals minus 2 squared, which is 4. And then e to the power of minus 2, so 4e to the minus 2. So therefore, the actual coordinates are going to be 0, 0. And they're going to be minus 2, 4e to the minus 2. And there we go. That's part B. I'm saying it like I finished the question. No. So determine the nature. So now what we need to do is take the x coordinates and substitute those into here. So if I substitute, so for part D, let me just write that in red. I've got at x equals 0, d2y by dx squared equals, and we just substitute it. So this is 0 because 0 squared. This is 0. So we've got 0 plus 0 plus 2e to the 0, which is equal to 2 times 1, which is just 2. And this is greater than 0. So therefore, the point 0, 0 is a minimum, because when d2y by dx squared is greater than 0, that implies minimum. So that's a minimum point. Minimum point. Okay. And then, at x equals minus 2, d2y by dx squared is equal to, because the other point is that x equals minus 2. We're putting that in. So minus 2 squared is 4. So that's 4 e to the minus 2. And then minus, so 4 times 2 is going to be minus 8 e to the x. And then plus 2 e to the minus 2. So if we simplify that, that becomes 4 plus 2 is 6. Take away 8 is minus 2. So minus 2 e to the minus 2. And this is a value that is less than 0. Therefore, we've got that the point minus 2, 4e to the minus 2 is a maximum point. And there we go. Now we're actually done with this question. It's actually worth quite a lot of marks. 3 plus 3, 6, and 10 marks. Yeah, that's pretty good. Pretty good. Okay, and we'll do one more, in this video, and then we'll do the others in a next video. So we have y equals e to the power of 2x multiplied by tan x. And it says show that the turning points on C occur where tan x equals -1. Okay, so turning points implies differentiation, so we need to differentiate. So product rule, we've got e to the power of 2x multiplied by tan x, which is a product. So we let u equal e to the power of 2x, and we've got that v is equal to tan x. Cool, cool, cool. Then we've got du by dx, which equals, so outside an inner function, e to the power of something differentiates to e to the power of that something, and then multiplied by the derivative of the inside function that was supposed to say multiplied by 2, because that's the derivative of 2x. So that simplifies to 2e to the 2x. And then dv dx, well, tan of x differentiates to sec squared of x. Okay. Again, this is one of those differentials that you learn. It's one of those standard rules, and it's actually given to you in your formula sheet if you're doing A-level maths. So the product rule, just writing it here, is u dv dx plus v du dx. Okay, so that means that our dy dx, substituting, so u is e to the 2x, dv dx is sec squared x, plus v, which is tan x, du dx, which is 2e to the 2x, and then because we're trying to work out or show that the turning points occur when tan of x equals -1, we put this equal to 0. And what can we do here? Ooh, well, we can factorize e to the power of 2x. So that gives us e to the 2x. And then we've got sec squared x. And then plus, here we have 2 tan x. And that equals 0. Okay. Then, there's actually quite a lot of stuff happening here. Okay. We can divide everything through by e to the power of 2x because we are confident that e to the power of 2x will never be 0. So we're just left with sec squared x plus 2 tan x. And we must have that is equal to 0. Okay, this is the bit where it gets a bit tricky. So this uses a bit of identities. Some people may know this identity, some may not. So let me derive it from first principles. So let's start off with the identity sine squared x plus cos squared x is identical to 1. Dividing everything by cos squared x, we get sine squared x over cos squared x, which is tan squared x. Well, let me just write it like this. Sine squared x over cos squared x plus cos squared x over cos squared x is identical to 1 over cos squared x. Sine squared x over cos squared x is tan squared x. Tan squared x. And then we've got 1, because cos squared x divided by cos squared x is 1. And 1 over cos squared x is actually sec squared x. So this is actually another identity that we've created from the other identity there. So tan squared x plus 1 is sec squared x. So that means that we can rewrite this all in terms of tan, because we know sec squared x is the same thing as tan squared x plus 1. So instead of writing sec squared x, I'm going to write tan squared x plus 1. And I've also got the plus the 2 tan x. And that's all equal to 0. Okay, moving on. I can write this as tan squared x plus 2 tan x plus 1, which equals 0. It's a quadratic, something squared plus 2 something plus 1. That factorizes to tan x plus 1 multiplied by tan x, plus 1, and that equals 0. That's the same thing as tan x plus 1 squared. That's equal to 0. So the inside bit must be 0. So tan x plus 1 equals 0. So therefore, tan x is equal to minus 1. And that's part A. We showed that the turning points occur when tan x equals minus 1. And the second part is to find an equation of the tangent to C at the point where x equals 0. Okay, so with part B, we need to take our dy dx. So our dy dx, let's just remind ourselves, just to write it here. Dy dx was equal to e to the power of 2x times sec squared x plus tan x times 2e to the 2x, and we want to know at the point x equals 0. So if we substitute x equals 0, we get e to the power of 2 lots of 0, which is 0, times sec squared of 0, but sec is the same thing as 1 over cos. So we've got over cos squared, and I'm going to put 0. I'm just doing this so that it becomes calculator friendly, because the calculator does not have a sec button, plus tan of 0 multiplied by 2e to the power of 2 times 0 is just 0. Okay, so that part becomes, well, e to the 0 is 1, cos 0 is also 1, and square that is 1, so that part gives you 1, and then plus, well, tan of 0 is just 0, so 0 times this other quantity is going to be 0, so we get 1. Okay, and what was the question again? Find an equation of the tangent. So we now know the gradient. So the gradient of the tangent is equal to 1. So we have y equals mx plus c. So that is just 1x plus c. And we need to work out what the c is. So we know x equals 0. And if we know that x equals 0, our y coordinate is going to be e to the power of 0 multiplied by tan of 0, which is equal to 0. So in actual fact, it's x equals 0, y equals 0. So substituting in x equals 0, y equals 0, 0 equals 0 plus c. So c equals 0. So in actual fact, the equation of our tangent is simply y equals x. What a satisfying answer and a good way to end this video. I will see you in the next one. Take care for now.